I'm hoping some people are still stuck in the traffic, but we will start in the interest of time. And some of you have been early. So, a very warm welcome to the UChicago Center in Delhi. I know it's a chilly evening, but I'm sure our welcome message and the discussion is going to make the evening warm. So thank you very much for joining us. The UChicago Center in Delhi is part of the university's 6 global centers and serves as a platform for academically rich and forward-looking discussions such as this. We also work towards supporting research communities in India, in the United States, and worldwide to forge collaborations. It serves as a space for alumni and students to deepen their engagement both in India and the United States. The center in Delhi also hosts a couple of high-impact programs, such as the Energy Policy Institute of Chicago's India chapter, the EPIC India. EPIC India is a leading energy and environment think tank and has done path-breaking work in this field. Our other program is International Innovation Core, which is a social impact fellowship program. The other program is Development Innovation Lab, which uses the tools of economics research to bring out solutions, innovative solutions, which impact the lives of millions of Indians. The other program is Data Policy Innovation Center, which is an exclusive collaboration with the government to enable the government to use data in designing the programs as well as implementing those. The center receives its academic direction from Professor Supratik Guha as the faculty director. Supratik will be chairing today's discussion, but before that, it's my pleasure to introduce Supratik to all of you. He's a professor at the Pritzker Molecular Engineering Institute at Chicago and a senior advisor to the Argonne National Laboratory's Physical Sciences and Engineering Directorate, leading the lab's microelectronics and quantum information science strategic efforts. Professor Guha led the Center for Nanoscale Materials, a US Department of Energy Office of Science user facility from 2015 to 2019. Before joining Argonne and the University of Chicago in 2015, he spent 20 years at IBM Research, where he last served as the Director of Physical Sciences. And Supratik has been he's been quite innovative in forging research collaborations in India, has been talking to stakeholders across board and encouraging the center to take some of the research that he's initiated as well as others in the university have done. And he's kind of been very generous with his time and has offered to host this panel. So over to you, Supratik, and thank you very much, all of you, for joining us.
Thank you. Thank you, Lenny, for this kind introduction, and welcome everybody to the center. I see a lot of familiar faces from the extended, I have a mic, UChicago Alumni Network. Thanks for coming. I think we have an exciting discussion ahead, the future of scientific and engineering research education, building a world-class workforce. As you know, there are, in my mind, sort of 4 different things that are happening that at this point overlapping with one another and interacting with one another that's changing today's world. There are these innovations that have been driven by computing, the cost of computing dropping, and the growth of AI. Everybody is familiar with that. Electric vehicles are going to be cost competitive with the internal combustion engine in another year and a half. Solar energy and renewables have become grid competitive compared to conventional means of producing electricity. And genomic medicine, the cost of deconstructing the human genome has dropped about a factor of 10,000 in the past, 10 years or so. And you're starting to see personalized medicine. So these things are all linked and are changing the way we are doing research and the way we should be educating our workforce. So this is a timely topic, I felt, and we've got a set of distinguished panelists here, 4 of them in person, and we have 3 online. So what I will do is I will very briefly introduce each of them, and then we'll have each of the panelists spend about 3 to 4 minutes giving you their thoughts on the subject. And then we'll jump into questions. I'll also encourage the audience to ask questions, and we'll just take it where it goes, okay? So let me briefly introduce people. Professor Rudra Pratap Singh, on my extreme right, a man with the white shock of white hair, is the founding vice chancellor of Plaksha University. And prior to joining Plaksha, Rudra Pratap was the deputy director of the Indian Institute of Science at Bangalore. And I would also call Rudra Pratap the father of Indian semiconductor nanotechnology. He was responsible for founding the very influential Center for Nanoscience and Engineering at IISc Bangalore, which has a world-class clean room that has underpinned a lot of that work that has come out of India. Then there's Professor Ananya Mukherjee. She is Vice Chancellor of Shiv Nadar Institute of Eminence, recently recognized as an institution of eminence. Now, prior to joining Shiv Nadar, Professor Mukherjee, who's an economist by training, was Provost and Vice President Academic at the University of British Columbia at Okanagan. And prior to that, she was a professor and on the faculty at York University in Canada. She was named in 2022 as one of the 15 most influential women in education by Business World. Then there is Professor Dhanya Chandrika Tulasidharan. She is presently the Dean of Academics at IIT Delhi. She has been a professor in the Department of Civil Engineering at Delhi, and she joined there in 2011 after finishing her PhD from IISc Bangalore. Now, her expertise is hydrological modeling for climate and for water sustainability. And then next to me is Professor Shomok Rai Choudhury. He is the Vice Chancellor of Ashoka University, where he's also Professor of Physics. Prior to this, Shomok was the director of the Inter-University Center for Astronomy and Astrophysics. He's a cosmologist and an astrophysicist. Prior to this, he was Dean of Science at Presidency University, and before that, he was on the faculty at the University of Birmingham. And online, we have three distinguished panelists. Professor Amit Patro is an electrical engineer, specializes in power electronics and VLSI systems. And Amit is the director of IIT BHU, and he has served in the past as the interim director of IIT Kharagpur, as well as its deputy director. Then there is Professor Kaushik Roy. Kaushik is the Edward G. Tiedemann Jr. Distinguished Professor of Electrical and Computer Engineering at Purdue University. Kaushik has been at Purdue since 1990. Prior to that, he was in industry in semiconductor circuit design, working at Texas Instruments in Dallas. So Kaushik is one of the most influential professors of electrical engineering in the US. He's graduated over 100 PhD students, many of whom have deeply influenced the fabric of microelectronics research in American academia, national laboratories, as well as industry. And then we have Dr. Franziska Greinert from the Technical University of Braunschweig. She's also online. Her research focuses on quantum technology education, and very recently, as an educator and researcher, she played a leadership role in the creation of the European Union-funded European Competence Framework for Quantum Technologies. And we're very happy to have her here because quantum information, as you know, is something that is a new area that is emerging, and almost every nation involved in leading-edge science and engineering is spending a lot of time trying to figure out a strategy for research as well as education in that area. So with that, let's turn it over to each of the panelists, and give us your thoughts. Why don't we start with Shomok?
Yeah, Pradeep, can I just interrupt for a minute?
Yeah,
This
yeah.
Kaushik,
Yeah.
I'm just going to interrupt for a minute. We are having a hard time, with the audio, it's jittery.
You're having a hard time hearing us?
Yes.
I see. Shomok, can you say something?
I think that's true for the other folks also in the web.
So let's figure out whether there's a single mic that's a problem. Can you hear me? Is this working? Then I'll share my mic.
And this is much better. I think this is better.
This is better. Okay. So I think you should ditch your mic.
Yeah, I think it's more important that you hear what the panelists have to say than what I have to ask, but I'll use the mic, yeah.
Right. So we're talking about future of science and engineering research education. And so let's start off by talking about how we see it now and how we think it needs to change to make us future ready. I work at an institution that is a liberal arts and sciences institution where we look at science and engineering problems as essentially an interdisciplinary issue. And we connect both undergraduate education and postgraduate education together to look at research problems. I personally believe the way to move forward is not to think of, and we're talking of building the future workforce for India, not to think of research in India, research education in India, as focused on getting a PhD degree. A lot of current research education in India focuses on their PhD programs. They are bound to subjects that are often confined to buildings, where people talk to each other in their own groups, in their labs, and of course work on really, really worthwhile problems that have traditionally been held in their departments as big research problems. I think globally what is happening is that people are realizing that the big research issues that are important to humankind, and we saw, for example, 5 years ago in the pandemic, COVID-19 becoming one of these problems. We are looking at climate change as one of the big problems. We're looking at the public health crisis in terms of the relation between health and environment. And of course, futuristic problems like what's going to happen in the quantum world. None of these things are confined to a single subject. In many of these cases, we can see that the boundaries between subjects as defined 150 years ago need to be taken down and for people to come together. And in India particularly, this is a challenge. Because in India, research and research education is confined mostly in the sciences to the institutes, whereas universities traditionally are not leading institutions in research. The transition is happening now, but if you look at what the situation was, say, 40, 30 years ago, you had research really, even the Indian Institute of Science, which is now a big pedagogical institution teaching undergraduates, was actually a research institute. And so research institutes mean that most research institutes are subject-focused, sometimes single problem-focused. And where the interdisciplinary research education will happen in the universities. And this is, I think, where research in the US, in Europe, in the UK, and many other places win because their research is mostly based in the universities. This is where the change needs to happen in India. It's already happening. And it's happening in the newer universities where organically interdisciplinarity has been brought in. And I think to begin with, we should think about how to break down these boundaries and encourage research not focused on the PhD degree in a single subject, but to look at how to think of problems in an interdisciplinary manner.
Thank you. Let me just go to online. Yeah.
Let's go to Amit Patro. Do you want to take 3 to 4 minutes to give your thoughts?
Yeah, sure. So, can you hear me?
Yes.
Yeah. Yeah, so
Yes.
carrying on where Somok has left, the university system in India actually was geared up to train basically, teachers. Those people will again become teachers in schools and colleges, and then they will, teach the next generation. So rather than doing research, where they concentrated more on understanding what is the state of the art and more of a learn and teach kind of technique. Learn mostly by reading, but with time, of course, many of the universities, especially these institutes of eminence and others, they have given a lot of emphasis on the research, but research takes time to to percolate down to the faculty mindset. In fact, I'm in a unique place where there is BHU and then there is IIT BHU. I'm seeing that this is a place where I can see actually how the transformation is happening with IIT being formed in 2012. There is a big emphasis on the research, right? And so I can actually see what is transformation that is happening with many faculty, especially what is happening is the younger faculty, they are coming back from a very good research institution, maybe in the country or abroad. But the earlier generation, they need much more time to really gear up to do research. There is another thing which has been there in India is that, what I understand in Europe and the US, the research is entirely driven, the fundamental research particularly, driven by the universities because there is no other place to go to. In India, what used to happen, especially in the earlier days, time is changing, is that whenever a company needs a technology, it goes to a company in the US, Europe, Japan, wherever, and then get the technology. So they didn't need to come to the faculty, to the universities. So that way, that neither the relationship got developed nor was there any demand on the faculty to do research. So these are changing. So I think that is good for our country, and I'm sure this will, become better and better, and India having aims to become Atmanirbhar and things like that. This will get much more emphasis. And let me stop here now.
Okay. Ananda?
Can you hear me? Kaushik, can you hear? I think it's a delay, maybe.
Can you guys hear Ananda?
We can hear, we will bear with it. I'm trying to get the best by wearing a headphone, but I think we'll just manage here. Don't worry.
Maybe, I've stolen Shomak's magic mic and maybe some of his thoughts too. So, in terms of the future workforce in STEM, but also in all disciplines, I think what I feel most strongly today is that it's not enough to train only brilliant engineers or brilliant scientists or brilliant economists or historians. We have to train whole human beings, or we have to educate for producing whole human beings. And why I say that is, in the sciences, even now, while we've moved a little bit to the problem-focused learning, that we're going to focus on the problem and the impact, there is not always a consciousness of the impact of what research could produce. And or sometimes there is for example, when somebody's trying to finish a PhD or even in an undergraduate honors thesis, it has become a very almost a procedural set of requirements. But for the researcher to think back about the impact of his or her research is not something that is broadly integrated in the way universities still function. And on the other end, I see this almost a too quick rise to impact, that I must produce a prototype of something which will raise a venture capital of X amount. And I don't think either are good models for a future workforce, because the world is has become extremely complex. Human needs are extremely complex. And so the balance between this overemphasis on instrumentalizing knowledge and on pursuing research as a researcher with critical thought, this balance has to be struck, and universities have a major role in doing that rather than in single domain institutions. The other very interesting thing I find after having come back to India after 35 years or 30 years is that knowledge is truly multimodal. It is not flowing from X to Y, but it is being constantly co-created, co-constituted, or could be co-constituted in different locations. And so to develop methodologies or pedagogies which can bring these different type of knowledges together, it's a very old debate in knowledge philosophy, but I think it has come to us in a very complex way right now, and we need to focus on it. Thank you.
Thank you, Ananda. Let's go back to the web or virtually. Franziska, do you want to give your thoughts on where you see quantum fit in all of this as we head to the future?
Yeah, so we expect a big growth in the need of a quantum workforce. So there's a big growth expected, but most of these people in the quantum workforce, they don't need a PhD in physics or even a dedicated quantum technology master's program or something. Most of them are engineers with a little quantum add-on. So what I personally would suggest is starting in standard engineering programs and adding 1, 2, 3 lectures or seminars or lab work to these programs to lay the foundations for quantum technologies and similar for other emerging technology areas, to prepare people for this new technological paradigm and make them ready to learn on the job what they really need for their specific job. So also this learn how to learn and get into the topic what is relevant for you on your own. This is something I consider really important for building the future workforce.
All right, thank you. Let's go to Dhania. I think your mic is...
Good evening. Thank you for the invitation, UChicago Center and Professor Guha first. In fact, the invitation was to Professor Rangan Banerjee, Director IIT Delhi. As he is out of station, I'm trying to fill in for him. I hope I'll be able to do justice. So the one I want to pitch in is based on, I'm going to reflect on the curriculum revision we have done recently after 10 years. In that curriculum revision, that was an exercise which was spread for more than 2 years, where each academic units interacted with industry, government, and all their stakeholders and tried to find out where we are lagging, how we don't want to change. Of course, they also don't want to change. We, academia, also don't want to change, how we can find a middle way. And in that curriculum revision, which we currently are running, for the first time, we actually brought in a curriculum for PhD. Till that time, the curriculum for PhD was the supervisor. That's the curriculum. There is nothing else. So we derived a curriculum, and in that, many things to in fact, with this goal, I could see that many of the factors that built in would in fact satisfy all these things. It will if at all it is implemented properly, it will create a world-class workforce of scientific and research manpower. How much interdisciplinarity we can bring into one program? It's just not possible. So we gave the flexibility to the students to take their courses and derive their path. So flexibility was the key word in our curriculum revision. Second thing, instead of this rote learning, syllabus-based rote learning, we give them more hands-on kind of learning. And how the instructors are going to inbuilt into their each courses, we have to see. But that was the vision. Third thing is that is a word called external connect was introduced into the curriculum. External connect means the PhD students and also the others they must step out of the campus. They have to go to a government institution or to the industry or at least to an outside foreign institution or at least to any other institution in India. Step out of IIT Delhi and learn. That was the external connect component. And so all these things. And then for the research scholars especially, we have brought in something called research empowerment. So they don't have to always be in their labs and produce the great research that they would be envisioning. But when they step out of the lab, they will be able to understand the societal relevance of the research they would be doing. Maybe they will be able to link the relevance of their research with respect to the national missions, at least, if not the global missions. So that was the whole idea. So all those things, there are more, but these are the major things we try to integrate into the curriculum. And as I mentioned, this is yet running. We are yet to get the performance measures of that. So in that, if I could divide that into 3 baskets, we try to redesign and to restructure the curriculum from the syllabus, from the exam angle, and from the pedagogical angle. We try to convince the faculty that we are not needed probably as instructors anymore. We need to be mentors. How to do that, we left it to the faculty to decide. Maybe I'm also a faculty. I'm still trying to sort out how to do that. And then the industry is there in our campus in one or other way. We have a research park, and I'm sure that all the institutions are involved with industry. But most of the time, industry is confined and they are kept at the periphery. They are not involved into the curriculum or the teaching. So our tagline was that how we can involve industry as a co-educator, which we are still sorting it out. For example, most of the institutions now have professors of practice and adjunct professors, but how effectively are we tapping those resources to get that or transfer that knowledge to our students? We still have to find it out. And also we realize that at the end, if we really want a world-class research manpower, we need to also keep an eye on the input. If the input is a great one, the output will certainly be a very much more greater one. So are we getting the right input? So it all depends on the market, how it is driving towards the pay packages and all. So it needs a lot of effort from the government, from the industry, to actually increase all these pay packages or guarantee jobs and all, which is not from the academia side, but I'm sure that they also would be thinking in line with that. But having said so, I would also like to have a disclaimer. As an academician, creating a research force is one of the objectives, but may not be the only objective. Because I need to create a graduate who is well-rounded, who has transferable skills, who is industry-ready. So society expects from the academia a much more balanced outcome. So this is one objective. Thank you. I'll stop.
Okay, thank you. Let's go to Kaushik.
Can you hear me, Pratik?
Yes.
Okay, great. Anyway, to start with, I believe over the last several decades, scientific and engineering education certainly has been quite successful. I'm not maybe talking exactly about India, but it did give us depth, rigor, led to remarkable technological progress. But the problem that I think we face today are kind of like energy, climate, AI, health, security, these are larger and more interconnected. They sit at the intersection of technology, certainly, but society, policy, economics, and so on. So the question then is not whether our education system worked in the past or not, it probably did quite well, but whether it's structured for the future. So with that in mind, the question is what kind of workforce do we actually need? And I believe that a world-class workforce is defined, certainly as somebody mentioned, by how many PhDs we produce. In most of the advanced technologies that we're talking about, the majority of the workforce would be the undergraduate technicians. And in fact, more interestingly, what we see is that the people who might have to retrain themselves multiple times over their careers. And so we have to look at education from a slightly different angle. So today's engineers and scientists are designing sort of, so to say, socio-technical systems. Whatever the decisions that they make, they have policy, ethical, societal consequences, and that means probably we need engineers who can work across disciplines. That we've been talking about that for a long time. Even in the U.S., we talk about interdisciplinary education, but then again, there are huge barriers even now. These engineers then still need to be able to communicate clearly, understand context, and the other elephant in the room, and that we must have to talk about, is AI. And AI is changing how the work gets done. So the students are going to use AI, and so our job is to shift our emphasis from, AI can do good execution in a lot of cases, but the proper judgment. The students have to be able to ask the right kind of questions. And I guess we'll talk more about AI a little bit later. But the other one that turns out to be quite important and essential is going to be strong coupling with the industry. However, we have to be clear in our mind that most successful industry-university collaboration that we have seen are those where students engage in certain problems early enough. But one thing that is really important is we don't want to lose academic independence or intellectual ownership. So that's all I would like to say. I'll start.
Thank you, Kaushik. Let's go to RP.
Thank you. Good evening, everybody. Pleasure to be here. So after 6 people have already spoken, there's very little left out there. However, we are talking about creating the workforce, or what is the world-class workforce. So, Supratik, I was just thinking about it, that India has created world-class workforce. You are a result of that. Kaushik is a result of that. Our graduates have been world-class all over the world. You see them performing, including in India, right? So it's not that we haven't done world-class workforce creation. When I looked at that, I wanted to unpack that into 2 bits, one in space and one in time. It looks like we're talking about world-class workforce in India, so that's in space. And in time, that now we are confronted with AI, and everything seems to be like we are all stuck like a deer in front of headlights, right? That's what's going to happen. So if we think of these 2 things, for India to do substantial jump in the workforce, world-class workforce creation, what needs to change is graduate school in India. If you see how our graduates have succeeded incredibly well throughout the world, particularly in US, the difference has been the graduate school. They have gone to great schools, done master's, PhD, and done very well. So that education, and even personally, I think that when I went there and went to graduate school, I saw a quantum jump in not just the kind of teaching, the kind of learning, but the kind of thinking. There was a really, really clear jump. So that's one thing that is standing out for me, that the graduate school in India needs to go through a complete transformation. The second thing is that our thinking has been very linear, undergraduate, then master's, then PhD. As a matter of fact, there were requirements in India that you can't do PhD unless you have a master's degree also, right? So that's how linear our thinking has been. And disciplinary linearity too, that, in only this discipline. All of that needs to break down completely. And as a matter of fact, I'm very happy that I have got the opportunity to do exactly that at Plaksha. It's a greenfield university, so we are doing every bit that I'm talking to you about. That no boundaries. We are talking about interdisciplinarity. How do you force that interdisciplinarity? It's not just about teaching different kinds of courses. It's the mindset of different courses, right? So bringing faculty from different disciplines, first to have dialogues among themselves, and then bring that dialogue to students. If you can't talk to each other, you are full-grown adult, how do you expect an 18-year, 19-year-old to make sense of, you teaching completely different thing, he teaching completely different thing, and I'm supposed to synthesize that when I'm 19-year-old? Nonsense, right? So if we can't synthesize and go with that kind of thinking to classroom, we are not doing justice, right? People say, engineers must be taught humanities courses. This has always been there. It's not new, right? The difference is that in our time, we did that for checkbox, and pressure went. It's just pressure release. You have all hard classes, let's go to sociology. It will be easy, right? Easy to get A. But that's not, it was because, you didn't have to do any math and you didn't have to get the right answer. Almost every answer is correct answer. So then, no, you can. It's good. That's what should happen in a panel, right? What I mean is you can debate there, right? But if you calculate a force required to move an object from A to B, right? There is no, question of your opinion. Newton defined it for you. This is how it works. And that's that. So I think that bringing these different disciplines together in the classroom to train our students to think differently, that is absolutely essential. You see the result of the linear thinking. As an engineer, I could design automobiles. I felt like, oh, wow, cars. Give everybody cars, right? They can. You never thought that what will happen to all the emission that takes place. Because you are just thinking locally that, okay, थोड़ी धुआं निकलेगी, क्या फर्क पड़ता है? But when all of it accumulates together, you get a global problem. Same thing with medicine. You give antibiotics to everybody without thinking that, okay, ultimately it is going to go to groundwater and it's going to, become, all bugs are going to become, antibiotic resistant, right? Through the pesticides, same thing. You are agricultural engineer, you design new pesticides for crop yield, doubling crop yield. It leaches through the water, goes to the, so the bigger problems that we created, we never thought of them. And now it is confronting us. So what does it tell you about education? It tells you that you need to create people who can think much broader. They can think about consequences of what they do, what they design, what they put out in the market. That's the kind of engineer or scientist you want to create today. And that requires a much broader knowledge base. But that broader knowledge base doesn't happen just by teaching. It happens by discussion, debates on campuses with different groups of people, with different scholars. That's the kind of environment you want to create in a university to build this world-class workforce that we are talking about.
Thank you, RP. Let me address a question to Ananya, Shomok, and RP in that sequence, and then I'll come to Amit and Dhanya. So the question for each of you is, over the past decade, right, roughly, we've seen the growth in India of high-quality private PhD granting institutions, right? And you represent 3 of these places. Where do you see the unique role that you can play, right? Both in research as well as in education? Maybe just a short answer on each. Ananya, why don't we start with you?
This is the magic mic? Okay. So first of all, we can teach that not all answers are right in sociology. That's one thing we can do. But there are no right or wrong answers, which is actually a much more difficult position than having a right answer and getting it wrong. So, I don't know if all of you know about our university. We are in our 15th year, and it was established, of course, by Mr. Nader at a time when he thought that the single domain institutions, particularly engineering, were not enough to deliver the kind of education that was required in India. So he certainly thought of interdisciplinarity as one big need, but also the research. So he was convinced that the idea of building research into undergraduate education and then throughout, and the idea of undergraduate students, faculty, graduate students, doctoral students, all on one campus working together across disciplines was something that was very important for India to have. So we have very much stayed true to that vision, that education is about the whole human being. It is about, we live in campus, I live on campus. Our campus residential model is a very important part of the education. So in going back to what unique role our type of education can play, first of all, it is the idea of research as not separate from education, that research and teaching go together. And you asked specifically about PhD granting institutions. So there also the idea of having PhD scholars who would also work across disciplines. And from the very beginning, the idea of what your PhD was going to produce in terms of the impact. And then what it created because of the emphasis on research and PhD, and we want to achieve much more in this than we have until today, is an ecosystem of peer work. And by that, I don't only mean peer review of journal articles, which happens, but that the youngest undergraduate student, irrespective of his or her GPA, can openly ask a question to the most erudite and senior professor without feeling scared, because we are all driving some kind of curiosity and research question. So this idea of a peer ecosystem, the idea of research and the idea of interdisciplinarity is what we can contribute. But as far as world-class universities are concerned, these were there from the beginning, but it wasn't there so much available to Indian students. And now I think we are in a stage where it is much more appreciated, and there is much less struggle in bringing very good students. And now, even though small in number, we have a 15-year-old worth of alumni who are doing wonderfully in different parts of the world. And that is that is the proof of not only the concept, the proof of the product, I would say, or the pudding. And so that's what we contribute, the holistic person who is driven by curiosity to pursue research and think of the impact.
Thank you. Shomok?
Yeah, let me extend that. I think your question was about what the new breed of universities, particularly private universities, can bring to the table. Of course, the larger institutions, the IITs, the ICERs have set up, and the ISC, of course, set up a very nice research ecosystem within the country. What I see as what the newer institutions bring in is what, for example, we do at Ashoka. We don't have the engineering departments or the medical school or the professional schools. It's a liberal arts and sciences school. And research plays a very important part within the fabric of the university. And that is where I think I talked about interdisciplinarity, not as a kind of buzzword, but it is the way these institutions are conceived. Interestingly, undergraduate education is, first of all, completely enmeshed with research. This, of course, started with the ICERs in India, and some of the ICERs were very successful in bringing research at every level. And we do that from the very beginning. After our foundation courses are over, we take in students who don't declare a major till their second year. The first year they do foundation courses, and they learn all different kinds of subjects. They have to do history, philosophy, economics, science, quantitative reasoning, environmental science, everything. Every single student has to do that. So they get the basic idea of interdisciplinarity. Then they declare a major, and from the very beginning, there are certain research projects they get involved in. And of course, they do a project in the final year, etc. So, and most importantly, one of the things that we emphasize is formulation of the problem is the most important thing. The research, even at the very basic level, is not answer-based, it's question-based. And I think that's going to be very important in the age of AI. When you have the AI tool which will solve the problems for you, you have to know how to ask questions. And people get together to ask these questions. And they see their faculty doing the same thing. I'll give you an example. Our history department has a biology lab. Why? Because our archaeologists in the history department are digging up Rakhigari, which is an Harappan site, 5,000-year-old pottery, where they found traces of food. And they're asking the question, was milk part of food 5,000 years ago? So they needed a DNA lab. So now we have an ancient DNA lab, right? This, in the traditional Archaeological Society of India, would not happen. Who are the people who are doing the digs? Our undergraduates. 30% of our papers have undergraduates in them, including nature science papers, right? That is one way you use this amazing base of young people in India get involved in research, and research means at that level group research. We are not depending on individual projects. We put them in groups, we think them to ask questions, and then they start working with each other. And we actually expect our faculty to do the same thing. And I think that is the future of research in India. I'd say one more thing about what we can bring to as a complementary institution to the research infrastructure of the public institutions that already exist in India, is that in the private sector, institutions have a larger flexibility of hiring people and also buying things. I mean, I worked at a public institution. I was the director of a central government institution for many years. And gosh, to buy equipment was so difficult. My PhD student postdoc can actually buy things on eBay and Amazon and assemble things in the laboratory. I could not do that in a public institution. Similarly, I can hire people off the, from foreign institutions, foreign citizens. I can have research associateships, pre-docs, research faculty, all kinds of things we can define which are not defined in the. So that really, really helps, and that has all helped a lot in our particularly outward-facing research programs. Our public health research, for example, involves a lot of hospitals in India who readily would share data with the private sector rather than share data with the public sector, it's much easier to do that. So there are niche areas in which one can actually use the fact that you're a private institution in a very, very constructive way. Thanks.
Thank you. RP?
Soma covered quite a bit of what private universities can do. And as a matter of fact, I moved from Indian Institute of Science to Plaksha because I realized that public institutions have certain inherent limitations because it's public money. And therefore, it comes with the territory. You can't wish it away, shouldn't be wished away. So when you need the kind of freedom that you need to really create radically different universities or different thinkers, you need a different kind of freedom, and that's what private universities provide you. Okay? So I see it as an opportunity that our public institutions are doing a great job. IITs have done remarkably well. IISc is known everywhere for its research might. But you do see that if you want to change engineering curriculum, which has been riding on, let's say, post-World War II chassis so far, if you want to change that, I challenge any IIT that can you change it overnight? You can't. That's the nature of existing institutions, right? But as a private university, you do have the freedom to throw away everything that you have seen and say, okay, here is a clean slate. Write new foundational training for our kids. Number one. Number two, that Somak pointed out, that you don't have to kill 4 years of childhood of our children to prepare for one exam, which defines your rank for your life. And you get plugged into some department in some IIT, which is all against your wish. You somehow tolerate those 4 years, and then you do whatever you want, right? And most of them change their mind and do something else. Why go through such torture? Why not create institutions where kids have the freedom to explore and choose what they want to do? And they don't have to go through 4 years of coaching to get through an exam to get admission. These are things that are required for this society, and that's what private institutions, new private institutions do provide. The other thing about research, how do you work with different institutions? As Somak pointed out, we can have even joint appointment with industry, 50% with Google, 50% with Plaksha. Totally doable, right? Or with foreign universities, joint appointments, totally doable, right? These are the kinds of freedoms that we can exploit to bring a really different kind of education and really different kind of research focus to our educational institutions or to the country. I think those are the big advantages that we have. Even in terms of research, if you go to foundations, go to private philanthropists and talk to them, it's a very different thing than going to DST asking for money, right? You have to be very, very focused on what kind of impact you create. Then only you get money from philanthropy, right? So that also helps. And the best thing I have learned, Supratik, is in private universities, you finally learn the value of money. When in public institutions, your salary is guaranteed, every expense is guaranteed, you don't understand that value. Here you have to earn every rupee, right? So you understand how to be really, really frugal, how to be very efficient and, run optimized operations.
So I take it sort of, if I sum it up from three of your responses, I interpret it as saying that what you like about or what you feel is unique are the degrees of freedom in various ways that are offered, right? Let me now turn to Danya and Amit as the leaders of two of the leading IITs in India, one of which is also one of the oldest engineering institutions in India. What do you feel are the unique challenges for specifically the IITs going forward? Dhanya, you want to start it off?
IITs also have challenges. Maybe I just want to add that it's my turn to object to your comments now. So you are going in this line. Anyway, let's start a light. No. So, coming to creating a research workforce, the main challenge has been the way the mandate has been given to IITs. IITs were made primarily to create, UG workforce, technical workforce, and improve the technical expertise across the nation and, of course, outside. So that was the mandate. So I remember when I joined IIT Delhi in 2011, we had 3 bullet points in our vision. Of course, teaching was our first vision statement. IISc, of course, was made to empower or come up with research workforce. Now, since our topic is on research workforce, I remember sometime in 2012 or 2013, in my initial years in IIT Delhi, the second bullet point was research, was moved to the first bullet point. It was a kind of re-emphasizing its focus on research, not diluting the teaching, for which we are famous for. But coming to the research, there is a structural problem, and it is not necessarily only for IIT. Structural problem is that we, across the world, we may not be focusing on the depth of the research outcome. We are still guided by the number of papers. So that kind of disadvantage we are trying to work out with. Now, to all these things, so we have got all the right ingredients. We have identified the problems, issues we face in creating research workforce, and slowly over the years, I could see, at least in IIT Delhi, we have been working on that and bringing to cover up almost everything. For example, bringing industry participation in terms of professors of practice, adjunct professors, and even a startup culture for PhDs also. That platforms are also there. And also global benchmarking, involving with the reputed universities across the world and also within India. For example, AIMS-like institutions where we could see a lot of complementarity, involving with them and coming up with joint PhD programs that has been kicking. I mean, we are putting a lot of focus on that in the past 5 or 10 years. So we have almost identified of course, the problems and try to cover up or come up with the right ingredients needed for the research force. Now, the questions what we have started to ask is that if I look at the numbers from 2018 to 2025, we have almost doubled up the PhD output from around 250 to almost like 530, I think, last year. That was the number of the PhD graduates we generated. The question is that, does our country need these many PhD graduates or across the world? So the job market, or are we assuring them the jobs? Now, the one learning outcome, the first learning outcome we have put up is that we are getting probably the best of the students, and we have the best of the faculty to train them. But are we creating independent researchers who can come up with research hypotheses and identify their problems and come out with methodological solutions? So all these questions, larger questions, need to be addressed. And which is, again, I can say that this has got the attention of even the ministry recently. Ministry is also questioning that, do we need to create this much research manpower, or do we need to divert all those things? And also the kind of research outcome we are producing based on a thesis, that's also been questioned. I'm sure that many of you must have read about the practical PhDs awarded by China. It was in Nature News. So some kind of such breakthrough, or whether it's the right step to go ahead. So we have to start debating on that. So this is a transition phase. So these are the challenges, maybe not necessarily faced by IITs. I'm sure that all other research institutions are also facing the same challenges.
Okay, thank you. Amit, do you want to comment?
Yeah, sure. Yeah, I agree with Dhanya on some of the points that she mentioned. Now, apart from that, I would also like to add a few more things. Is that although these issues of financing and going to the government for funds is still a challenge in the sense that we have to convince a democratically elected government to give you funds for your research. So as you can see, anybody can imagine that how difficult it would be, because the government is also very, very conscious that it should not be too easy on the academic institutions. Suppose they have 100 crores or so for a quantum research lab, they cannot just give it to you, even if the person who is dealing with it is very, very convinced about it. So we have to follow the processes and staying within the government, protection, with as Rudra said that salary is protected. So we have to be also very, very receptive to the needs of our donor. Even the government, the government, it's the public donation. You can say it's the public fund. So when those aspects are there and we do understand and we accept and we manage, and let me also mention that in the recent past, in fact, particularly last 1 year, lot of rule simplifications have been made, particularly in terms of scientific procurement. Right. Kind of things, as the scientists, we know academics in science, so we know that certain instruments like HR10 is actually made in the world just by a few companies. So once that is known, government is also willing to give us the freedom. So you write it down and you state it, and let it be vetted by experts, that you really don't have to go through a so-called tender and query, keep waiting for months and wait for multiple beats. And so things are getting simplified. Very happy. Things will improve further once these things are in place. And apart from that, there is the other part, which is the research culture. And this, as I probably said in the beginning also, this is something that takes time. And having come from Kharagpur, where I used to find that, on an average, I would say more than 60 to, I would say more 70 to 70% people are involved in different types of research, including industry funded projects, sponsored research, consultancy, kind of things. While coming to a new institution in IIT BHU, which is of course new, I found that the percentage of faculty involved is much less. And there's nothing wrong. I mean, it's the natural thing. In fact, in Kharagpur also, when we were faculty, we joined as faculty almost 40 years back now. So we also found that the research was just coming up. And slowly the culture has changed. People know that everybody has to do research. In fact, I remember that once I finished my PhD, some of my senior professors said, "Okay, Amit, your future is done. You have finished your PhD, nothing more in your career. Nothing. You don't have to. You don't have any more challenges, so to say." But thankfully, challenges remain, and the more challenges you're able to accept, you get more and more challenges. So in the same institution in IIT BHU, we have also started different types of processes so that people do take up the challenge. In fact, we have created a grant called a challenge grant, where the requirement is that faculty across departments must collaborate, and sometimes across institutes also. Particularly, we have a BHU, very, very good facility with medical and agriculture and sciences, all are very, very strong there. So they can collaborate with them, and if they come up with a proposal, then part of that will be funded, right? So that's the challenge. So you propose a project, good project, which may cost. I mean, 1 crore rupees. I think Francisca may find it difficult. So, 10 million rupees is the project cost. We will give you 40% of that to you upfront, so that you can start your work, and and then show some preliminary results, and then develop the full proposal and go to funding agencies for the full funding or more funding. So our faculty are really very, very enthusiastic, and I think I don't have the count yet. It's a very recent phenomenon, but about 150 faculty got involved, which is about almost like a 30%, or rather, yeah, more than 30% of our faculty. So this is how we can do that. So interdisciplinarity is something we're insisting on. And another point which is also very important, I appreciate what Somok has mentioned, that the formulation of the problem, selection of the problem is most important. In place of actually solving it. So I tell my faculty and my research students that you first pick a good problem, and even if you can't solve it 100%, you're better off than taking a very simple and an artificial problem and solving it 100%. So these are the things we have to drive. We do have these opportunities. It is not that as the government we're completely tied up. Our hands are pretty open, and as Dhanya has also mentioned, we are open to collaborate with industry, have faculties as professors of practice, distinguished professors, and industry visits, projects, conferences. Everything is allowed, and also entrepreneurs. In fact, we have also, even in a new institution, so-called new in the sense that as IIT is new, we have several faculty-led startups, apart from student-led startups. And so opportunities are there. There is no difficulty about having equal, we are almost at a level playing field as far as, the freedom is concerned. Thank you.
Thank you. So what I would like to do is take some questions from the audience, but before that, I would like to ask each of you, but I'm going to request you to give me your answer in 1 minute, no more than this, please. Okay? If you had only 1 minute, right, in the proverbial elevator with someone, what would you highlight as your one most important focus in going forward and creating a world-class scientific and engineering workforce? Just that one thing that would be the most important for you. RP. Why don't we start with RP?
Original thought. That's it. My whole emphasis is teach students to have original thought and pursue it, and have an environment that supports such kind of dialogue and debates to strengthen their ideas and pursue it to the fullest. Original thought, original scholarship is what I mean by that.
Thank you. Thank you very much. Let's go to Franziska.
Yeah, so I would say awareness of opportunities. So you don't have to be able to do everything on your own, but you have to have an idea of what is possible and whom to ask in case of problems.
Okay. Why don't we stay online? Kaushik?
Right. So I'm going to talk from the India perspective, if I may. Certainly India has an extraordinary scientific and engineering talent, and we all know that we have one of the best engineering education, undergrad, I must say, in the world. And there's an absolute need for better graduate education. We talked about that earlier. But the limiting factor, I feel, is not the ability. The students have to see the future in building things like hardware, energy systems, medical systems, manufacturing, with stability and impact. And when those, if the pathways are clear and not undervalued, then the talent wouldn't flow elsewhere. And that's been happening in India. So I think, if it's valued and if it's clear, I think that's not going to flow outside of India.
So Kaushik, you're kind of saying that focus on hardware going forward, or not undervalue it going forward.
Yeah, I think they have to see the future, right?
Yes.
The impact that they can have.
Okay. Amit, one key focus.
Let me put it this way: that we had a history of codification. Let me explain. What I mean is that Indian workforce, even today, the jobs that they get are in the IT, so-called IT industry, and they are supposed to become coders, and that's how they get their jobs. Now, I think what we need is a decodification, right? They need to become away from coders, and there I again align with Kaushik that they have to actually build things, right? Which will actually do things, and that is what will actually give value to them and value to them.
Okay, thanks. Shomok?
I would say keep your nails short. I'll explain. My first mentor in science was V. Radhakrishnan, who was C.V. Raman's son, at that time Raman Institute's director, and I spent 3 months as an undergraduate working with him. As I was leaving him, he said, look, remember, keep your nails short, because in my family, the upper caste scientists would keep long nails to show that they only thought, they didn't do things by hand. And the idea is, roll up your sleeves. People should learn how to use their hands, work in maker spaces rather than in labs, try to deconstruct and construct things. That is the way to start, how to turn yourself into a working engineer and scientist.
Tanya?
So, what I have seen over these years, I don't think that we are getting the cream of the country to do the research, for us to make the research workforce we are envisioning. Now, that is the change I want to see in this country. That I believe that the students or the candidates are driven by the celebrations they can see in other fields, and they are not often following their passion. So something at the UG level, if not at a much more early level, school level, to understand their passion and make them aware of the needs of the country and the national mission and get them hooked to that. I'm sure that if we can generate that passion at the early level, all these 4-year wasting, if at all we are thinking about that, that will not happen. They will not be driven by these kind of names or the pay packages. They will be driven by their passion. And we will automatically be able to produce. It's an idealistic thing, I'm saying, but that's a change I want to see.
Thank you. Ananda?
So 2 quick things. One is I want risk taker faculty who would come and ask bold questions. They don't know what the answer is. I want people to have belief in a young institution which attracts diverse students with diverse talent and take risks. And the second thing I want is not only to talk about research manpower, but research woman power a little bit, because we do graduate the largest number of women STEM graduates in the world, and then something happens later. And we really do not want the so-called AI revolution to also have a similar focus, which is not inclusive.
Okay. Thank you. So again, if I were to kind of condense, I interpret it as all of you are kind of saying, think big, think original, find the people who think big and original, and after you've thought about it, build it, right? Don't just think. Okay, great. Why don't we turn it over to the audience and take a few questions? Whoa, lots of questions. Okay. Okay, I saw that hand come up first. We'll go to you after that. Thanks. Again, please keep your responses short because I want to be able to encourage. This is the biggest.
A few questions together.
Yeah, keep the questions short as well.
Yeah.
Let's do one question at a time, short answers. One of you answer it. Yeah.
Thank you. My name is Salil Pandey. I actually went to IIT Kanpur, and also I'm a graduate of University of Chicago, Booth School. And we come with challenge everything. So my thinking right now is listening to you guys is that we are at a very crucial moment right now where India can actually just really capture something which is there. Let me just take a minute to explain. There is AI wave, and that is like unstoppable. What that is going to do is going to give you an opportunity for scale and scope. Scope we are talking about already, which is interdisciplinary. That's a scope for me. Scale, because you don't have to do the basic grunt work. It's over. Don't spend any time on the grunt work. How do you operationalize this opportunity, which actually AI is giving to us, to really capture the true scale and scope by creating Silicon Valley around every major institution? Start imagining that every institution is a Stanford. Just to start dreaming. At least there is no tax on that. Let's dream that every institution is a Stanford, around that is Silicon Valley, and we are solving difficult problems. So, Dhanya, when you were saying that we need to look into the national mission and figure out what those problems are, we are talking research here. Please include the word development in that, because development is inside the corporates, inside the industry. You solve, I have a startup here, we work on career acceleration. You take one of my big problem that I'm facing, and solve that. We have the resources, we have the know-how, we have the data, we have the insight. We will work very collaboratively with you. But I think what's happening is that we are caught up in doing stuff as opposed to literally taking this moment, which is a pivot basically. It's d2y by dx squared is equal to 0 right now. So we need to literally basically capture this moment, kill every bit of grunt work. And why not just take it down even to the high school? Why high school students still have to do the grunt work and the rote learning? So that's where I would like comments from you guys in terms of how you think. Is it a moment where you can capture?
Okay, let's take a few more quick, because I see this as more a comment, right? So maybe she was the next. But keep your question short, please, okay?
In fact, my question is really short.
Good.
We are seeing there is a volume of doctorates in the market today. We talk of world-class research workforce. My question is, who is to take the onus of supporting this world-class research workforce, find a suitable world-class workplace?
Who wants to take that? Sure, yeah.
So, ma'am, the lady from IT Delhi, I forgot your name. I fully echo what you said, right? The cream of our country today, unfortunately, at IITs and elsewhere, want to work at hedge funds, right? They don't want, a very small percentage of them want to work on cutting edge scientific problems. And I think there is like a fundamental rethink we need here. It's not that maybe they're not exposed to that there's drug discovery, there's material invention using AI. There's no shortage of cutting edge impactful things which could turn into billion-dollar companies. But I think there's just too much of this Me Too following, like either go to an IIM or go to a hedge fund and make tons of money. I think we need to really, really have a paradigm reshift into how young people need to be thinking very boldly. And one quick question, if there was a government person on the panel, just like we need to learn from China. China was able to attract the brightest, which studied abroad, back to its shore, the so-called bring the turtles back home policy. I think somebody in the government should be thinking about that. Thanks.
Okay. Thanks. Again, I view that as a comment. Go ahead. Quick question.
Thank you very much. Thanks a lot for this very enriching discussion. So actually, we would just like to share very briefly the interdisciplinary perspective that you have all shared, and that's one of the central things. So I'm Dr. Sudeep Patra, so I'm from OP Jindal Global University, and I have my colleague Dr. Sharik Hussain and Shashank. So we run a center there on complexity science and also on quantum information theory. So we work on a very emerging field called as quantum cognition. So it is an interface between quantum information theory and human decision making. And this is a kind of field where, by definition, it has to be interdisciplinary. So, say, for example, Sharik and myself, we work in mathematics, and Shashank comes from law background. So the questions that he raised, we do not know. But then we are really surprised by these questions. And then we try to see that whether we can come up with mathematics and we come up with scientific thinking in that direction. So we are very interested to know that how these kind of centers we can collaborate more and more. Say, for example, we are trying to reach out to Ashoka and Shiv Nader and Laksha and others. So that would be very much one thing that we would be very passionate about, to collaborate more. So, Sharik, would you like to add?
Would any of you like to comment on that?
Visit us first.
Yeah. So,
Of course, more the merrier. We are very happy to have that kind of collaboration, and actually we advocate that.
Yeah.
Right?
And towards that
Network.
end, I'm Ray, sorry. Could I? Yeah. Towards that end, I somewhat represent. This question matters to me and this discussion matters to me on two accounts. First, as a 21-year-old law student who is trying to find what meaningful literacy feels like for the future, but also as a researcher in complexity theory, trying to figure out what the trajectory of transformation, which many of us are not just intuiting, but have somewhat mentioned in our questions and our curiosities. How is it that not just as institutions, but as networks, because this is an experience that I've had working with the center, that it's easier for a center in India to collaborate abroad as opposed to collaborate with thinkers and academics within the country. So as opposed to what perhaps Mr. Pandey alluded to, as opposed to having particular Stanfords, I believe that if there is an opportunity, we could, of course, build on networks, or which robust networks which intelligentsia can build future transformations and make the most out of the era that we live in. So just wanted to know about what this networks as opposed to institutions approach could perhaps follow.
In response to your question about we collaborate more with abroad, as institutions abroad, than ourselves. It's very true. People say, "Oh, I'm late because I'm from Gurgaon," and I always say I came from Canada. So we do have that problem, but we have students like you. So, and we have similar students on all our campuses, I think, who are really interested in interdisciplinary problem solving. And so these centers, which we are able to set up quite easily, virtual networks, I think we should just decide that we want to do. We have four or five universities here, the two IITs here. We can certainly work on the network. And the centers, to be very honest, as an administrator, I can say that sometimes the center gives me a framework with which to work administratively. But it should not become a barrier to real collaboration between researchers, which it does. But we are conscious now that we don't want to be driving away young students with the rigidity of centers, but we just want it to be as an institution to attract. So I would be very happy to take forward, I think all of us would be, anything that comes out of this kind of discussion.
Thanks. Let's take some questions from there. There was,
So Pratik, there was a question by her. May I respond to her?
Yeah, why don't you do that?
Yeah, about PhDs.
Right.
So, it just feels like we are producing too many PhDs. Actually, you heard from Dhanya also. It's not true. The total number of PhDs coming out from India in STEM is about 17,000 right now, from all universities. We have some 1,300 universities and 70,000 colleges. Incredible number, right? And largest number of educational institutions in the world, by the way, in a country, right? But look at our neighbor, China, right? That is also our envy, something to take inspirations from. They produce largest number of PhDs in the world. Today, they are producing more than 75,000 PhDs in STEM alone. It's almost double what US produces, right? They are able to use them, right? Because they have built industries which use these when the generative AI model came out of that, you heard that in that company, how many PhDs were working. For us, we don't have those companies. But what you have now is what are called GCCs, you must have heard of, Global Competency Centers. And they are growing exponentially in number in the country. Today, there are about 2,000. And just 5 years ago, they were like 500 or something, okay? So that number, what Global Competency Center means is that these are the companies that need people with deep knowledge, people with, graduates with real expertise in an area. In other words, PhDs, right? So there is going to be a lot of demand for PhDs in this country. We are not producing enough. If you talk to some of the thought leaders around the world, they tell you that what are you guys doing? Not producing enough PhDs. Our problem is not just that not producing enough PhDs, not producing good kind of PhDs, quality PhDs. I told you that graduate school in this country needs to undergo radical transformation.
Let's take that question.
So my question is actually, my name is Jawahar Kumar. I am a research scholar at IIT Kharagpur, and I am a faculty at IMS Noida in MBA faculty. So my question is in a different direction actually. All the institutions like IIT, IIMs, or the private university, state university, the central university, they are producing good researchers. But when the researchers from IIT and IIMs, they are coming and joining to the state university, like Sir has mentioned that they don't have fund. So those quality of workforce, when they don't have resources, they are getting died. Their ideas are getting died there. So how that area can be filled when we have a quality of workforce and they are going to the downward, like in the state university where there is no resources. So how we can utilize those workforce? Like the IITs and IIMs are nurturing those workforce, but if in the search of job security, if they are going downward to the state university where there is no funds. So how those workforce can be utilized in a better way? Like private university like Sivnadar or the Soka University, they have plenty of fund. But the state university, why it is lacking?
Okay. Any one of you want to take it? Yeah, go ahead.
So one thing I must tell you is
you want
that...
me to try? You want me to give some answer?
Sure.
Yeah.
Sure, go ahead.
Do that. Go ahead.
Yeah, actually, so we have to help each other. As Dhanya has mentioned, that IITs are also not having good research for these days. So the best thing is to collaborate. So you contact persons of who are working in your area, and then start collaborating. And once you do that, the IITs or whoever organization with whom you are related, they will get benefited, and you will also learn. And then, once you become familiar and you are also known as a active researcher, you will also start getting your funding. And then I thought that this could be a way forward.
Can I add something?
Yeah, quickly.
Yeah. So, the problem that you are talking about bugs me a lot. It's one of those things where PhD students have not been trained to be enterprising enough. Okay? If you are a faculty member in any university, what prevents you today from collaborating with anybody in the world? Somebody in Korea, somebody in Japan, somebody somewhere else in your area. What prevents you? There is no funding in your state. Who cares? There is tons of funding in the world, right? It's just getting out of your comfort zone, sticking your neck out that, hey, I have this expertise, I'll be able to deliver this. Don't keep thinking about go to DST, write that proposal, get that money, Not required. You have expertise, stick your neck out, find partners from around the world. Everybody is online. You have no excuse.
There was one question there at the back, yeah.
I have a very simple question, sir, that we are talking about the future workforce. And what about bringing those workforce into the research and development dynamics who are already having experience of 20 plus years? Because 20 years back, we were not having the same facilities which are available. We are having Atal Incubation Center, we are having Innovation Council, we are having a Startup India, we are having Hackathon, though various universities are coming up with paper presentation, what about those unutilized resources which are there in the industry for the last 20 years and they missed the train? So shall we come up with a new policy to attract this talent?
Who wants to take it? You want to take it? Yes.
We, at Shivnadar, for example, we do have a PhD program for working professionals. So we just started one in computer science with people with 15 years experience can come back. And we were overwhelmed by the response we got. The Chartered Accountancy Institute, for example, has now accepted Chartered Accountancy as a degree with which you can start a PhD program. So these things are happening, the expertise.
To add to that, if I may, this channel is open since many decades. I am sure that in IITs and such institutions, this channel is already there. Not only for PhD, people who have only done bachelor's and have jobs, they can also come to the master's program also. So they even industry-sponsored dedicated master's program and industry-sponsored dedicated PhD channels are all there. And to facilitate these industry, most of the IITs do have part-time channel also. So those can be explored.
Let's do one last question, and we'll go here. And then after that, there's going to be some refreshments. Please go ahead and ask your questions there, and I'm sure the panelists will be happy to answer. Please go ahead.
So I know I'm between the refreshments, huh? That's a tough task to follow. So I have kept quiet only in the sense that I have been in this business of, with IBM, I was too, in Almaden Research Center. I was in magnetic data storage. IBM went through very difficult time, so did Hewlett-Packard, so did Quantum. All the US-based companies, they were losing their digital edge to Japan. Commerce Department put together some funding. I wrote a proposal. We pulled together all the universities and all the industry in that area, 5 years and out research, so that the immediate competition would not take over. And we improved our data storage by a factor of 10 to the power 9. 1 billion times. Do you have any metric like that to show us of all the ideas that you're talking about, that you can improve a given technology, no matter whether it's quantum computing, whether it's something else? Let's see what you have. I pulled together people from Berkeley, but then I found a small university, some old guy sitting in the corner doing excellent work on beta phase of C3 and 4. Took that idea, implemented it, pushed out 2 products from IBM, right? So government saw that. Today, there are only 2 companies making hard drives, Western Digital and Seagate. Where are they located? In the US. So we kept the competition from Japan and others away from all this. That's the success story that has been repeated over and over time. So from what we call National Storage Industry Consortium, we moved to Information Storage Industry Consortium, where we brought in the Japanese and the Singaporeans.
So, I'm sorry, you had a question for the panel?
So the question is, what is your metric of what you're talking about? That's the bottom line question. Okay, a lot of talk about PhDs and programs and this and that. I'd like to know what is the output and how you're going to measure it.
So I think we can measure it by your metric. What you started off by saying is that you did have a quantum jump in terms of some parameter, which was for you storage, right? Now, what is happening is that we have global challenges that are coming up in scientific technology, which now is inspiring people to come across the globe and come together and take up those challenges. And so it is important, you are absolutely right, for us to get involved in some of these challenges. So quantum, of course, is one of the major things. People are trying to build quantum computers, and so we have to do that. I mean, I'll give you an example from my own experience. So I was involved in some of these very large mega projects in astronomy and astrophysics in my previous job at IUK Pune. And 2 of the things that we got involved in were to build a gravitational wave observatory in India, LIGO, which is going to happen in Maharashtra on Indian soil. And the other one was becoming a partner in building the world's largest telescope in Hawaii. And India became 20% partner in that. Challenge was given to us that if this particular telescope will have 492 mirrors, and 100 of them will have to be built in India. Who will build them? So what we did was, for 2 years, we scoured small-scale industries in India, MSMEs, SMEs, to find out who can build things for a global project. And we found amazing small family-owned industries in Pondicherry, in Jamshedpur, in all over the place, who could build little components that would be assembled in building these mirrors and their control systems. It's possible. It's possible for, when there's a challenge that comes to us, we can do this. Now, we built that. We're going to build these mirrors for the world's largest telescope that will be built in Hawaii. And components for that will be built by more than 100 small-scale industries in India. So, and we also found other industries that won't work because their entire ethos won't work. I think identifying the right problems are important. For you, it was the problem of miniaturizing storage. These problems come to us. For gravitational waves, the same thing. We are going to measure things that are smaller than the atomic nucleus, the disturbances that are smaller than the atomic nucleus. And so we'll have to find the technologies that will solve them. I think the technology is there, the manpower is there. And furthermore, I'll end by saying such challenges inspire young people to rise to the challenge. Also bring back people who are working abroad, prevent people who only think that big research can happen abroad, and get engaged in Indian industry. That's very, very important. So I think it's important to get these projects.
Funding to IIT Delhi. I'm sorry to say, I got very little out of it.
Okay, with that, let's end for the evening. Thank you, panelists. Those on with us virtually and those on stage. Thanks again.
Thank you. Just one second. Yeah, I wanted to request Supratik to hand over.
Yes.
What about our friends overseas?
Yes.
They're going to have the refreshments.
Well, to all those who could not ask a question or have a burning question, this is, yes, there are refreshments outside. You can talk to the speakers here. But I must say that this is the beginning of a discussion like this. So by no means we will be able to conclude on a topic like this. So this is the beginning of discussion, both in terms of where this would take us academically or where it would take us practically, building networks and stuff like that. So we couldn't have had a more illustrious panel than this to initiate the discussion. And thank you, Supratik, for doing this.
Thank you so much. And we have a few gifts.
Excuse me, one group photograph.
Unfortunately, those online, I cannot hand you gifts. Maybe in another 100 years.